Hi to everyone. I am Dr. VNSR Venkateswara, working as an Associate Professor in the Department of the Freshman Engineering from Institute of Aeronautical Engineering, Telangana, Hyderabad. Today I would like to give the topic of the potable water. Potable water means it should be all the free from the dissolved salts and can be applicable to the domestic purpose, is nothing but a potable water. Potable water, the common requirements for the potable water is should be clear, colorless and free from the all the dissolved salts. It should be free from, it should be odorless, it should be soft, it should be abundant and cheap. Organism and disease causing bacteria should not be present. The dissolved oxygen should be 5 to 7 ppm. Water treatment for domestic use employs the following steps. There are mainly 4 steps, that is screening, segmentation, filtration and disinfection. First one is the segmentation. It is used to remove the suspended impurities by passing water through skins having a large number when floating matters and retained by them, and it is the vertical bars with perforations. Water is passed through them where the suspended and floating impurities are removed. So in the see the diagram, water in input area from left side and centrally it present in vertical bars with perforations having like small holes, and right side is water outlet. That means initially the water is allows through a left side pattern and introduced into a vertical bars, first vertical bar, and then introduced in a second vertical bar and filtered by suspended impurities and water outlet. So by the screening phenomena we can remove the suspended particles. And second one is the sedimentation process. In this process, removing fine and suspended colloidal impurities by the water to stand undisturbed in a big tank about 5 millimeters deep. That means most of the suspended particles settle down at the bottom due to the force of gravity. The clear supernatant water is then drawn from the tank with the help of the pumps. The retention period in a sedimentation tank ranges from 2 to 6 hours. Fine suspended particles like mud particles and colloidal matter present in the water cannot be settled by the plain sedimentation process. Sedimentation with coagulation. The process of removing fine suspended and colloidal impurities by requisite amount of the chemicals, nothing but coagulants, to water before usage. That is nothing but a sedimentation with coagulation. Coagulants when added to water forms an insoluble gelatinous flocculant precipitate which traps very fine suspended impurities, forming bigger flocus which settle down. The coagulants mainly used are alum, ferrous sulfate, sodium aluminate, etc. That means the equations are following. Aluminum sulfate reacts with the calcium bicarbonate to give the aluminum hydroxide. Calcium sulfate plus 6 moles of the carbon dioxide. By the balancing the chemical equation, 1 mole of the aluminum sulfate reacts with the 3 moles of the calcium bicarbonate and to give the 2 moles of aluminum hydroxide plus 3 moles of calcium sulfate plus 6 moles of the carbon dioxide. And second one is the sodium aluminate reacts with the water, nothing but hydrolysis of the sodium aluminate to gives the aluminum hydroxide precipitate plus sodium hydroxide. And third one is the magnesium sulfate reacts with the sodium hydroxide, gives the magnesium hydroxide plus sodium sulfate. And fourth one is the ferrous sulfate reacts with the magnesium bicarbonate to give the ferrous hydroxide with the byproducts of magnesium sulfate and bicarbonate. And finally the ferric hydroxide reacts with the oxygen with the water to gives the ferric hydroxide. That means oxidation of the iron takes place with sedimentation with coagulation. And final one is the filtration process. So it is the process of separating colloidal and suspended impurities by passing the water through a porous bed made of fine sand and other different sized granular materials. Filtration is carried out in a scanned filter. It consists of a top thick layer of the fine sand placed over the coarse sand layer followed by the gravel. Water comes from the top. The suspended particles present in the water are bigger size than the voids in the sand layer, are retained there itself and water becomes free of them. The sand layer may get choked after some time and then it is to be replaced with clean sand and further action. The main advantage of the filtration is the removal of all suspended particles, colloidal impurities and organic matter. So this is the phenomena of the filtration process. From left side we see sintered water in and break pressure chamber, and centrally it introduced into water. In between fine sand layers are present, after that coarse sand, after that gravel is present. That means 3 layers of the present. First one is the fine sand, and second one is the coarse sand, and third one is the gravel. Under rains it gives the coagulant float, and finally we get a filtered water outside that is present in the right exit. And next one is the disinfection process. Disinfection is nothing but the process of removing pathogenic bacteria, virus and protozoa from the sample of water. The following methods are mainly occurred by the disinfection process. First one is the boiling, and second one is the by boiling by adding a bleaching powder. Third one is the by direct chlorination. Fourth one is the by adding chloramines. Fifth one is the ozonization. Final one is the by adding potassium permanganate, KMnO4 formula. By boiling process, this is mainly applicable to the generally used in the domestic purpose. By the collection of the water by various sources, nothing but municipality tap water or mineral water, it may be either before usage it must be boiled before drinking purpose. Then only the temporary carbonate hardness can be removed, and if there is any bacteria it can be killed by boiling process. And second one is the by adding bleaching powder. This is the phenomena to most probably used in the municipal water treatments. They are used the bleaching powder in the large tanks. It can act as a disinfectant to remove the bacteria. That means chloride is mainly used as a disinfectant element. Third one is the by direct chlorination phenomena. In direct chlorination phenomena, chlorine means either gas or in the concentrated solution from the produces the hypochlorous acid, which is a powerful germicide. That means chlorine reacts with the water to give the hydrochloric acid plus hypochloride. Hypochloride further dissociates hydrogen plus oxychlorides. When germs reacts with the oxychloride, finally the germs are killing takes place. What are the advantages of this direct chlorination phenomena? It is most economical, require little space for storage, stable, does not deteriorate, and storage does not introduce the calcium. What are the disadvantages of this direct chlorination phenomena? Excess chlorine produces the unpleasant taste and odor. Excess produces irritation on mucous membrane. And ozonization phenomena, it is also one type of the method to kill the bacteria from the sample of water. Ozone is produced by passing a silent electrical discharge through cold and oxygen. That means 3 moles of the oxygen converted into 2 moles of the ozone by balancing the chemical equation, nothing but stoichiometry. Ozone is highly unstable and breaks down in the liberating nascent oxygen. That means O3 plus O2 plus byproduct of O. This is the nascent oxygen. Nascent oxygen is a powerful oxidizing agent and kills all the bacteria as well as the oxidizes the organic matter present in the water. The contact period is about nearly 10 to 15 minutes and dose is 2 to 3 ppm. What are the advantages of the ozonization? Ozone sterilizes, bleaches, dechlorises and dedorizes of the water. Excess of the ozone in water is not harmful as it decomposes to give oxygen. Ozone improves the taste of water, highly potable, is thus sterilized with ozone. What are the disadvantages of this method? Ozone is a very expensive process, that means cost effective. Ozone is also corrosive agent. It corrodes stainless steel, cast iron, copper and rubber. That means main 2 disadvantages. The one is the expensive process and it produces the corrosion phenomena with the stored water tanks. So this is the overall block diagram of the municipal water treatment for the obtaining the potable water. So initially the source of water passes through a screens, undergoes a coarse filtration. Next one is the large tanks are present, which is the water should be settled down up to 2 to 3 days, and add the alum coagulants are added. After that, sand filter is present. This sand filter is containing the 3 layers: gravel layer, fine coarse layer, and another layer. Because of the sand filtration takes place, the best filtration. After that, aeration is occurred. Aeration means by passing of the oxygen to maintain the required levels of the oxygen present in the water. And after that, apply the phenomena nothing but chlorination. So chlorination is the phenomena in the nascent chlorine can act as a disinfectant to remove the bacteria from the sample of water. It can be finally stored storage tanks, and it can be collected the required people from the various users. That means it is nothing but the overall phenomena of the municipal water treatment to get a potable water. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.